Hello, welcome to Answer. In this class, we're going to talk about ammonia. What is this gas ammonia? Ammonia is a compound of nitrogen. It consists of nitrogen and hydrogen. This gas is a colorless gas at room temperature with this chemical formula, NH3. We have 3 hydrogen atoms and 1 nitrogen atom forming ammonia. In its solution form, it is called ammonium hydroxide or aqueous ammonia. This inorganic compound has a pungent smell. In its concentrated form, it is dangerous and caustic. Ammonia is lighter than air with a density of about 0.769 kilograms per meters cube at standard temperature and pressure. It is the simplest stable compound of these elements and serves as a starting material for the production of very many commercial important nitrogen compounds. It is also widely used as a fertilizer. That is, the bacteria in the soil breaks down the nitrogen compounds in manure to form ammonia. The smell of ammonia is always noticeable around barns and stables where farm animals are housed. It is also used in the manufacturing of explosives such as the nitrocellulose and the TNT. Also, it is used in the production of soda ash and in the oswald process to get nitric acid. We are going to discuss these uses further. Very small traces of ammonia gas are found in the air, but we can prepare this gas in the laboratory. How do we do this? Ammonia is prepared in the laboratory by heating a mixture of an ammonium salt and an alkali. In order to do this, we need these apparatus and chemicals. First, we are going to need a round-bottomed flask, a glass tubing. You're also going to need a drying tower, several gas jars, mortar and pestle, cardboard cover. You're also going to need calcium hydroxide and ammonium chloride as the ammonium salt, and calcium oxide, litmus papers. So the first thing to do here is to place small amounts of calcium hydroxide and ammonium chloride in a mortar. These are our reagents. Then we grind the mixture well using the pestle and put it in our round-bottomed flask. By doing so, we arrange the apparatus. After doing so, we arrange the apparatus. The flask containing the mixture, you see, is being set in a slanting position. Why? This is in order to prevent water which condenses on the cooler parts of the apparatus from running back into that flask and causing it to crack. We also used calcium oxide, that is quicklime, in this setup. The reason as to why we're using it is to dry the gas. It acts as a drying agent. Why? This is because ammonia reacts the other common drying agents. We're going to look at those reactions later. So the next thing to do, we heat the mixture here gently and collect ammonia gas. What do you observe on the cooler parts of the flask and the delivery tube? What you see here is water vapor. Water vapor is formed in the reaction. Some of it condenses on the cooler parts of the flask and the delivery tube. If the flask is not kept in this sloping position, the water can run back into the hot part, making it crack. Let's put a moist red litmus paper at the mouth of the gas jar. What do you see? This red litmus paper turns blue if the gas jar is full. This indicates that the gas jar is full of ammonia. Ammonia is a more volatile base and is displaced by a less volatile base. For example, sodium hydroxide, potassium hydroxide, and calcium hydroxide. That's why we use calcium hydroxide and ammonium chloride to produce ammonia. Here is the equation for that reaction. You have calcium hydroxide combining with ammonium chloride to form calcium chloride, ammonia, and water. The ionic equation for this reaction is we have the ammonium ions combining with the hydrogen ions to form ammonia gas and water liquid. What property is indicated by this method of collection? When you see this setup, ammonia is collected by upward delivery. Why? This gas is less dense than air. Ammonia reacts with the usual drying agents like anhydrous calcium chloride or concentrated sulfuric acid. That's why I mentioned that we're using quicklime or calcium oxide as a drying agent. So concentrated sulfuric acid will react with ammonia to form ammonium sulfate. Calcium chloride similarly will react to form a complex compound with ammonia. Here is the equation for the reaction. Also the equation for the reaction between ammonia and sulfuric acid. Therefore, we use calcium oxide as a drying agent. Basically, that is how dry ammonia is prepared and collected in the laboratory.